Welcome back, grade 12s. You're with me, Helen, and that means that this is Life Sciences. And of course, we have a big thank you to say to Liberty for sponsoring our program today. But it's not just today's revision session that's going to be able to help you. You make sure you go and download the Tenfold Education app and check us out on our YouTube channel at Mindset Learn. And in those hours when TV isn't working and you haven't got us to help you, you actually have got us to help you because we're in your back pocket on your cell phone. All right, before the break, we said that examiners complained that students very often confused terminology. So let's pick on some of the things that cropped up in last year's paper and see what was confusing the learners then, because we don't want it to confuse you this year. So one of the terms, or one of the groups of terms, was the difference between sperm and semen. And students tended to use these terms interchangeably. But in life sciences, they mean very different things. All right? So when we're focusing on sperm itself, we're talking about a cell. We're talking about the very specialized cell. Look, it's got this head part to it, it's got a midsection or a neck, and it's got a very long tail. And all of that is one cell. Here's the nucleus. Here's some mitochondria. It's filled with cytoplasm, and it's got a very specialized organelle called an acrosome in the front that is going to help dissolve its way into the ovum. That is one cell. The sperm is one cell, and it is a gamete or a haploid cell. When we talk about semen, we're talking about sperm plus we're talking about nutrients plus we're talking about some fluids, as well as some, also in a fluid form, a pH buffer that is going to stop acidity either in the urethra or in the vaginal canal from killing the sperm cells. So we've got a whole group of things making up semen. Where did those things come from? Well, the sperm came directly from the testes. The sperm was produced in the seminiferous tubules in the testes, and when the sperm moved through the vas deferens, it collected nutrients, other fluids, lubricating fluids, and things that help the pH to be controlled, or the levels of acidity. And all of those came from the accessory glands, the prostate glands, the seminal vesicle, the small gland called Cooper's gland, and they all added their ingredients. And at the end of the day, we can't call that mixture just sperm. Sperm is only one component of the liquid that is semen. All right? So those two terms cannot be used interchangeably. You can't refer to sperm as semen, and semen is far more than just sperm. Okay, you got that one? You're not going to make that mistake at the end of the year? Of course not. Here's two more terms that are frequently confused: centromere and centrioles. All right, I can see how this one gets confused. We've got the centro and centri in the term, so it is very easy. It's very simple to think about which one is which. So let's work out by looking at this diagram which is which. The little structures that hold chromatids together are centromeres, whereas the structures that form the spindle fibers are the centrioles. Okay, so it's very easy for me to explain that. How are you going to remember it? Well, I want you to look at this part of the word centromere. And it almost looks like we could say the one E is a chromatid, the other E is a chromatid, and the R is like the centromere holding the two chromatids together. And the centrioles end in the word S. They are going to form spindle fibers. Little tricks like this help you to remember confusing terminology. It's probably only because I'm so old and I use these terms all the time that I remember them. But I know when I was a student, I used to play little word games with the terminology to help me remember it. And there's nothing wrong with doing that in your case as well. Let's move on. Commonly confused terms, uterine wall and uterine lining. They both have the term uterine, which means to do with the uterus. That much is clear, but the uterine wall and the uterine lining are two very different things. The uterine wall is the thick, muscular wall of the uterus. I'm taking it now and I'm shading it in with little blue stripes. That is the uterine wall. And the uterine wall is very muscular. The uterine lining lies just inside the uterine wall on the inside of the uterus. It lines the uterus. It forms an inner lining and it has another name. Do you remember the name of the uterine lining? I can hear some people shouting it out. It is called the endometrium. All right, and the uterine lining is what is going to break down and be passed out of the body during menstruation. But the uterine wall is always going to stay there. The uterine wall is permanent. It is the sides and the base and the top and the bottom and all the way around the uterus. But the uterine lining builds up under the influence of the hormone estrogen and progesterone. The uterine lining builds up, and if there is no pregnancy or fertilization taking place, that uterine lining breaks down and the lining or endometrium is passed out of the body. The uterine wall can't break down. That uterine wall is very much the structure of the uterus. So it would be very much like your uterine lining could be like paint on the wall inside your house. You can change that coat of paint all the time. One year you can have a green wall, the next year a pink wall, but the walls of the house stay there permanently. All right, you're not going to make that mistake? No, of course not. That was so last year. Not going to happen to you. Two words that are also similar, or terms, corpus callosum and corpus luteum. And this time, the two words are in two completely different parts of the body. But they start with this word corpus. And corpus is Latin for the word body, a structure, a part of something. So both of them have this word body in the term. Callosum means very tough, and the very tough body in your brain, the corpus callosum, is the tough connective tissue that holds the two hemispheres or two sides of your brain together, right? So it's like really tough tissue that holds the two sides of the brain and keeps them together. And in fact, nerves from, for example, that eye, let's say your left eye, cross over the corpus callosum to even the right side of the body, and we see that information from the left side of the body gets fed to the right side of the brain. So what we've got here with this corpus callosum is like a very strong piece of glue that holds the two sides of the brain together, but allows also for the transmission of information across from one side of the brain to the other. So that's your corpus callosum up in your brain. Corpus luteum, and the word luteum means yellow, is the body that is produced from the Graafian follicle. Once the Graafian follicle bursts and allows the oocyte to move out during ovulation, what is left of the Graafian follicle very quickly becomes this yellow body called the corpus luteum. And do you remember what the corpus luteum does? What it produces? It starts producing the hormone progesterone, which ensures that the endometrium or the uterine lining is kept in a good condition in case of a pregnancy resulting. All right, so we've learned quite a few confusing sounding terms. How about this one? Amnion and amniotic fluid. Now we can see that they have the same root to the word, but the amnion, if we look at this picture of a fetus inside the uterus, the amnion is a membrane that goes all the way around the fetus. It is closest to the fetus. And the amnion secretes the amniotic fluid. So here, the amnion is making the amniotic fluid. It produces it. So we can't confuse those two terms. The amnion is the structure that produces the amniotic fluid. And you know that the amniotic fluid acts as a bit of a shock absorber. It acts as an insulator for that growing fetus. All right, are we learning things? Are we making sure that we're not going to confuse some terms? This is a commonly confused term, and I'm not surprised. Why didn't scientists choose two words that sounded different? Glucagon and glycogen. All right? Glucagon is the name of a hormone that is produced by the pancreas. Now we know that the pancreas is going to produce two hormones. It produces insulin and it produces glucagon. The insulin helps the liver to store excess glucose as glycogen. Glucagon forces the cells to convert glycogen back into glucose. A wonderful example of negative feedback. So glucagon is the name of the hormone. Let's write it up here. And glycogen is a storage molecule. It is made up by taking many glucose molecules and linking them together to make storage molecules. And sometimes there are branches with our glycogen. But it is a polymer. Do you remember what a polymer is? We take many monomers or building blocks and we bond them together to make a polymer. So our glycogen is the storage molecule here in the liver. The glucagon is going to convert glycogen into glucose. It's going to instruct the cells of the liver, also some cells in your skeletal muscles, to convert that stored energy into easily accessible energy found in the monomers. So there we have it. They do sound very, very similar, but you're going to have to find ways of remembering that glycogen is the storage molecule and glucagon is the hormone. That's the way that you can also remember it. Glucagon is the hormone. We've got an ON, we've got an ON. Glucagon is the hormone. All right, and now we come to two more commonly confused terms. And this time they are commonly confused because of the similarity of the first word in the term. Seminiferous tubule and seminal vesicle. And you can see where these names come from. They're all derived from the idea of semen, that fluid that carries the sperm. All right? So, seminiferous tubule are these spaghetti-like tubes inside the testes. And the seminiferous tubules are where sperm is made. Sperm, all right? Not semen. Sperm is made inside these seminiferous tubules. So there are specialized cells, diploid cells, in the seminiferous tubules that undergo meiosis to produce the haploid gametes known as sperm. And here in this picture, there's where we would find our seminiferous tubules in the testes. But when the sperm is ejected from the testes, it's going to go via the vas deferens. There we go via the vas deferens. And it's going to go on this journey where a seminal vesicle and a prostate gland and little Cooper's gland are going to add substances to the sperm to result in semen. All right, so the seminal vesicle is this little gland over here. It's an exocrine gland that's going to add liquid and fluids to the sperm to help move it along, and it's part of the 3 accessory glands that in fact make semen that carries the sperm. All right, let's take a little bit of a break again. I hope you're managing to get down these confusing terms, and that means that you won't make mistakes that last year matrics made. But short ad break, and when we're back, we'll carry on looking at things confusing.